It did not begin with missiles. It began with a blackout. Before the first light touched Caracas, before the city even understood it was morning, something else went dark first. Screens flickered, frequencies jammed. A defense network built to see beyond the horizon suddenly saw nothing at all. And when more than 100 aircraft moved toward Venezuelan airspace, the radars that were supposed to scream stayed silent. Not destroyed, not bombed, silenced. Overwhelmed by electronic warfare, hunted by anti-radiation signatures, drowned in their own noise. Within hours, a system marketed as anti-stealth could not detect a single incoming jet. And that is where the real story begins. For years, Chinese weapons were sold as unstoppable by sheer scale. Hundreds of warheads, the world's largest navy by ship count, expanding missile forces, expanding air power. On paper, it looked like Thanos snapping his fingers. One move and balance shifts. That image sold, especially to countries that could not afford Western prices. When one air defense battery costs 5 times more than its Chinese alternative, the choice becomes financial, not ideological. And Beijing knew this. Cheap systems, long-term loans, flexible financing, no upfront burden. Bangladesh bought submarines. Pakistan expanded fleets. Venezuela stacked radars. It felt like a masterstroke. But here's what most people missed. The glitter came with cracks, quiet ones, ships developing structural fatigue too early, jets grounded with engine failures, radar grids collapsing under electronic pressure, missile batteries operating in isolation when they were supposed to function as a unified shield. At first, only defense analysts noticed. Then entire air defenses began failing in real combat. Pakistan's systems struggled to coordinate under electronic warfare. Cambodia's batteries couldn't intercept neighboring aircraft. Iran's radars faltered against stealth penetration. Venezuela's network collapsed before the first wave completed its approach. 3 theaters, same pattern. And this is where the tension rises, because when a weapons system fails once, it's a malfunction. When it fails repeatedly across continents, it's structural. Modern warfare is not about slogans. It's metallurgy, microelectronics, software architecture, institutional discipline. If alloys can't handle thermal stress, airframes crack. If turbine blades lack microscopic precision, engines burn out. If processors lag behind cutting-edge semiconductor nodes, radars freeze under electronic attack. If networks are centralized without redundancy, one hit brings down the grid. And when production speed outruns verification, quality becomes a casualty. The most uncomfortable part? Inside China's defense ecosystem, deadlines are political. Speed is survival. Reports of overworked engineers, burnout, sudden collapses, corruption investigations, falsified inspections, they are no longer whispers. When urgency replaces iteration, inspection becomes paperwork. And when paperwork replaces engineering, failure waits quietly for combat to expose it. The world saw numbers and assumed inevitability, but numbers without reliability are theater. And when real aircraft entered contested skies, the theater ended. What followed wasn't just a battlefield failure, it was a credibility shock. And once credibility cracks in the defense market, it doesn't shatter loudly, it erodes silently, contract by contract, buyer by buyer. The question is no longer whether the systems looked powerful on paper. The question is whether scale can compensate for structural weakness. Because in modern war, silence before dawn can be louder than any explosion. But perhaps the most revealing weakness is not material, it is organizational. The People's Liberation Army remains structurally centralized. Tactical autonomy is constrained by political oversight. In high-speed conflict environments, decisions must occur within seconds. Waiting for approval, 5 minutes, 10 minutes, alters outcomes. Modern warfare is networked, distributed, adaptive. A centralized command architecture under electronic stress becomes a vulnerability rather than an advantage. When communication links degrade, decentralized systems can continue operating. Centralized systems hesitate. All of this traces back to a moment that rarely appears in procurement brochures. In the mid-1990s, during tensions in the Taiwan Strait, 2 American carrier groups entered contested waters. China could not respond symmetrically. The lesson drawn in Beijing was not subtle. Speed and scale must compensate for historical inferiority. Overwhelm before intervention, saturate before response. From that point forward, quantity became strategic insurance. Defense budgets expanded at double-digit rates. Shipyards accelerated, missile brigades multiplied. The goal was not perfection, it was sufficiency at scale. For years, that approach appeared effective. The global financial crisis slowed Western militaries while Chinese production continued expanding. Artificial islands rose in the South China Sea. Anti-access systems proliferated. The Navy surpassed competitors in hull count. But volume conceals complexity. Systems that perform adequately in controlled exercises behave differently under real combat conditions. When tested against coordinated electronic warfare, stealth penetration, or sustained operational tempo, latent weaknesses surface. Export data now reflects that shift in perception. Chinese arms shipments have declined relative to earlier periods. Market share has slipped. Growth among Western suppliers contrasts with contraction among Chinese firms. Many buyers remain concentrated in a narrow regional band, particularly Pakistan. Beyond that circle, hesitation grows. Some governments have slowed or canceled contracts after observing others' experiences. The reputational cost exceeds the statistical decline. Inside China, leadership has acknowledged the credibility problem. Anti-corruption campaigns have removed senior defense officials. Major state-owned enterprises have faced scrutiny. Production schedules have been delayed as inspections intensify. A recalibration appears underway. The forthcoming 5-year planning cycle emphasizes reliability over speed. Civilian technology sectors are being integrated more deeply into military development in an attempt to leverage higher quality standards. Export strategies are shifting toward proven platforms rather than experimental designs. Dual-use technologies are prioritized to maintain influence while minimizing visible risk. Whether this recalibration will succeed remains uncertain. The structural drivers that produced rapid expansion have not disappeared. Geopolitical pressure persists. Regional disputes continue. Trade route dependencies remain acute. The objective milestones, 2027, 2035, 2049, remain embedded in strategic discourse. Rebuilding credibility requires time. Time is precisely what accelerated militarization sought to compress. What occurred over Venezuelan airspace was not merely a tactical failure, it was a stress test. A demonstration of how systems behave outside controlled parameters. And it suggests that the true contest is no longer about how many platforms can be produced, but how many can endure pressure without systemic collapse. At this point, the structure shows strain. Not collapse, not yet, but strain that cannot be masked by numbers alone. The strain becomes measurable when you map the sequence backward, not from the battlefield to the factory, but from the failure to the architecture that allowed it. Because what collapsed in those airspaces was not simply hardware, it was a design philosophy. Chinese systems were built around integration that appears sophisticated on paper, but depends heavily on central command nodes. In Venezuela, the air defense grid was structured around layered radars feeding into consolidated control centers. Once electronic warfare targeted the primary nodes, the surrounding batteries did not degrade into autonomous cells. They stalled. Target data did not propagate laterally. Interceptors waited for instructions that never arrived. The network was technically intact, yet functionally paralyzed. That is not a malfunction. That is a structural dependency. In Pakistan's coordinated response during cross-border strikes, a similar pattern emerged. Surface-to-air batteries operated in parallel rather than as a synchronized mesh. Communication bandwidth saturated quickly under jamming. Without resilient fallback protocols, each unit defaulted to local operation with incomplete situational awareness. This is the difference between distributed architecture and centralized architecture under stress. Western doctrines over decades evolved toward mission command, decentralized authority with network redundancy. China's model preserved vertical oversight. In peacetime exercises, it appears disciplined. Under electronic pressure, latency becomes fatal. The material weaknesses compound the architectural ones. Advanced alloys determine fatigue thresholds. If titanium blends contain micro-impurities, stress fractures propagate invisibly until operational tempo exposes them. Composite fuselage sections require uniform resin curing cycles measured within narrow tolerances. Inconsistent thermal control during production introduces microscopic voids. Those voids absorb moisture. Moisture expands under temperature gradients. Delamination follows. None of these defects are visible during ceremonial flyovers. They emerge after sustained sorties. Engine technology presents an even narrower margin. High-bypass turbofans and military afterburning engines depend on single crystal turbine blades capable of enduring extreme heat without grain boundary failure. Producing such blades at scale requires metallurgical precision that took Western manufacturers decades to stabilize. China's domestic engine programs improved significantly, but operational lifespan and thrust consistency still lag behind their Western equivalents. When export customers encounter premature engine degradation, maintenance cycles accelerate. Spare parts inventories deplete faster than projected. And here, the second vulnerability appears: logistics. Unlike Western suppliers, which maintain global maintenance networks and forward-deployed technical teams, China's after-sales infrastructure remains concentrated. Spare parts pipelines stretch across continents without dense regional hubs. During Venezuela's confrontation, nearly half of its radar components were already offline, awaiting replacement modules. Pakistan resorted to cannibalizing parts from one vessel to keep another operational. Bangladesh abandoned entire platforms rather than absorb escalating maintenance costs. In peacetime, such inefficiencies remain contained. During crisis, they translate into immediate capability gaps. Semiconductor limitations further constrain adaptability. Modern radar arrays and missile guidance systems rely on processors fabricated at advanced nanometer scales. Under heavy electronic attack, systems must reconfigure signal processing in real time. Processors limited to older fabrication nodes generate more heat and process data less efficiently. Gallium nitride components, essential for high-frequency radar performance, require thermal management precision. Overheating degrades output stability. In Venezuela, radar arrays reportedly lost coherence under sustained jamming rather than shifting to alternate frequency bands effectively. That indicates software and hardware integration limitations, not simply operator error. Corruption accelerated these weaknesses. Internal investigations within the rocket force uncovered inspection falsifications and maintenance anomalies in strategic units. When oversight becomes procedural rather than substantive, quality control transforms into documentation rather than verification. Substituted materials pass through supply chains. Test results align with expectations rather than performance. The removal of senior defense officials in recent years was not cosmetic. It was acknowledgement that systemic oversight had eroded. Yet the deeper mechanism lies in strategic psychology. The Taiwan Strait crisis in the 1990s did not merely motivate expansion, it implanted urgency. The conclusion drawn by planners was that the window for decisive action in any future conflict would be narrow. Therefore, saturation and speed became primary objectives. If quantity can overwhelm intervention before adversaries mobilize fully, quality deficiencies may remain irrelevant. This logic shaped procurement priorities. Production quotas gained precedence. Deployment milestones became political benchmarks. Over time, that bias institutionalized itself. Research and development cycles compressed. Iterative testing shortened. Military-civil fusion programs attempted to accelerate innovation by leveraging commercial sectors. While this improved certain domains, drones, consumer electronics integration, artificial intelligence applications, it did not automatically close the gap in foundational heavy industry disciplines like advanced metallurgy or precision engine manufacturing. Those require generational refinement. Export markets absorbed the consequences first. As reports of malfunction accumulated, perception shifted. Arms procurement is not solely transactional, it is reputational. Once systems are labeled high risk, the discount required to offset perceived unreliability increases. China's global market share slipped gradually. Growth among competitors, the United States, France, South Korea, Japan, contrasted with stagnation among Chinese firms. Revenue declines within major state-owned defense enterprises reflected not just geopolitical shifts, but buyer hesitation. Beijing's response now emphasizes recalibration. The forthcoming planning cycles prioritize inspection reform, stricter procurement oversight, and integration of higher standard civilian manufacturing practices. Rather than advertising experimental platforms aggressively, export portfolios are narrowing toward proven systems. Pakistan remains a core anchor customer, providing operational feedback within a controlled strategic alignment. Dual-use exports, Coast Guard vessels, surveillance drones, logistics platforms expand influence without exposing high-end systems to immediate battlefield scrutiny. However, structural change requires time horizons that conflict with geopolitical urgency. Strategic objectives tied to specific target years remain embedded in policy language. Regional tensions in the South China Sea, cross-strait calculations, and trade route security pressures continue to incentivize rapid capability growth. Balancing credibility restoration with accelerated modernization creates internal friction. The credibility crisis is not total collapse. China retains enormous industrial capacity, expanding naval tonnage, significant missile inventories, and sustained investment. But the underlying question has shifted. It is no longer whether China can produce weapons at scale. It is whether those systems can maintain coherence under multi-domain stress, electronic, logistical, organizational, and political, without cascading failure. In Venezuela, the collapse unfolded in hours, not because numbers were insufficient, but because integration faltered. When a single command node fell, redundancy did not compensate. When electronic pressure intensified, processors overheated. When interceptors launched, coordination lagged. These are not isolated defects. They are manifestations of a system optimized for speed confronting a battlefield, optimized for disruption. If Beijing succeeds in re-engineering its defense ecosystem toward resilience rather than rapid accumulation, the trajectory may stabilize. If not, further real-world exposures will compound reputational erosion. In strategic competition, perception shapes deterrence as much as hardware does. Once doubt enters the equation, allies hedge and adversaries probe. The current phase is not explosive. It is evaluative. Observers are measuring, buyers are reassessing, planners are recalculating timelines. The question is not whether China can recover. It is whether institutional momentum allows sufficient time for correction before the next stress test arrives. And in modern conflict environments, stress tests rarely announce themselves in advance.